Sorry, I guess maybe that, I'm trying to get this iPad thing to work, but it seems kind of ridiculous sometimes. All right, so anyway, so let's look at what we had. So what we saw, let's go through this really quickly again. We had 3 frames, 2 handlebars, 8 wheels, and we saw that we could make only 2 bicycles. And we'd have a frame and 4 wheels left over. And so the handlebars are the limiting reactant. And so we should kind of define what a limiting reactant is. A limiting reactant determines the maximum amount of other reactants that will react, or that could react, say could react, and a maximum, more importantly, the maximum amount of product that can form. So limiting reactant, 1 determines the maximum amount of other reactants that could react, and 2 determines the maximum amount of product that can form. 3, it gets completely consumed, right? So if I look at this situation we saw here, there's no more handlebars left. They're all become bicycles, whereas there's stuff left of the other stuff. So let's also define the excess reactants. Oh, so, and I wanted to say before we do excess reactants, for that little comment I said, use limiting reactant for all calculations. All right, excess reactant does not completely react. Some is left when reaction is done. Okay, so that's excess reactant. There's a couple other concepts I'd like to define too. We'll come to these in a second. Another one's called a theoretical yield. Is the maximum amount of product you can make. And then finally, so we have time, percent yield. And this is actually an equation. The percent yield is equal to the actual yield divided by the theoretical yield times 100. Okay, so let's continue. So there's kind of a set of steps for these. So limiting reactant steps. So the first step is to use each reactant to determine the maximum amount of product. And so there's kind of a stipulation for this. It's 2 calculations. It's actually the first step's the hardest step. The other step should be easier. It's 2 calculations. And they should find the same product. And then I guess lastly, you need a balanced equation again. Okay. So, once you've done that, then the reactant that makes the least amount is the limiting reactant. And another outcome. So these are basically, this is just an outcome of step 1 or an analysis. Also, that amount of product is the theoretical yield. It's also an outcome. Okay, so let's do an example. Instead of using the ammonia one, I'd like to use something that has 2 products, just so people don't get confused. It will help you on the homework. So let's actually take an example of an acid-base neutralization. Calcium hydroxide reacts with hydrochloric acid to form water and calcium chloride. I want to show that the molar mass of HCl is 36.46 grams, and calcium chloride, calcium hydroxide, excuse me. We should find calcium chloride too. Calcium chloride is 110.98 grams. Water, of course, is 18.02. And then calcium hydroxide is 74.10. So you need the molar masses. So I guess maybe step 0 is balance, right? And so if I look at this, well, there's 1 calcium on each side. I have 2 chlorines there. There's 1 there. So I'll need to put a 2. Once I've done that, I'm looking at hydrogens. There's 2 hydrogens here and 2 hydrogens there, which means there's 4 here. There's only 2 over there. So I'll put a 2 over there. And when I do that, it balances the oxygen. So I should balance and molar mass is really handy. Okay, so then step 1 is 2 calculations. If you want, I'm going to show you a shortcut. I'm going to go just to moles of product. And again, I'm only going to choose 1. Usually the problem will have a product that's interesting. Maybe water's not so interesting. Let's do calcium chloride. Choose 1 product, right? 2 calculations. Okay, so I'm going to take, let's get the problem here. So I haven't written the problem. So if, let's come up with a problem. If 28.5 grams of HCl react with 48.7 grams of calcium hydroxide, comma, how many grams of calcium chloride could form? Question mark. Okay, so for this one, actually I could back up and do a simpler version of that. Would you guys? Oh, close the app. You didn't have to restart. Okay, well, I guess that, sorry about that. Anyway, let's do it. Should we look at a molecule one first? Do you want to see parts, or do you guys want to just see the math? Do you have an opinion? Does anyone? Oh, there's stuff down here. Oh, I'm sorry. I was stuck in my, okay. You guys are chatting with each other. That's good. Okay, so someone wanted to do the easier one after. Okay, let's do the hard one. This is the harder one. So I'll do the hard one. Okay, so there's 2 calculations. So the first calculation, I'm going to take the hydrochloric acid, 28.5 grams of HCl times 1 mole of HCl over 36.46 grams of HCl times, what's the mole ratio, is 2 to 1. 2 moles of HCl to 1 mole of CaCl2. Now, in this first part, it's really a test, so we could just find moles, like I was saying. I'm just going to find moles. We can do that. So that's equation 1. Let's call that A. Equation 2, B. Whoops. Okay, so equation 2 is use the amount of calcium hydroxide. 48.7 grams of calcium hydroxide times, now the mole ratio of calcium hydroxide is 1 to 1 for calcium chloride. Whoops, that should be calcium chloride on the top. God darn it. Let me skip forward. What did I do? I need molar mass. Excuse me. Okay, so I need, what was it? Oh, 7410. 74.10 grams calcium hydroxide, 1 mole calcium hydroxide, and then I need the mole ratio, which is 1 calcium hydroxide to 1 calcium chloride. Okay, so anyway, then it's calculation time. I'm going to check these. So 28.5 divided by 36.46 divided by 2. So this one, let's see, I have 3 sig figs here for an infinity. So this will be 0.391 moles of HCl. Okay. This one, hopefully this one will give a different number. Let's check this out. So 48.7, sorry, skip that, divide by 74.1, whoops, 48.7 divided by 74.1 times 1 equals, oh, that's quite a bit more, isn't it? Is that it? That would be 0.657 moles. That's not HCl, excuse me, that is calcium chloride. Moles of calcium chloride. Okay, so anyway, pardon me. God darn. Okay, so now we just look at these two. And we just say to ourselves, we say, okay, which one's less? We say, this is less. So therefore, okay, so this is step 1, 2 calculations. Step 2 is the reactant that makes the least is the limiting reactant. The reactant that makes, so 2 calculations, find the same product. Step 2, reactant that makes the least amount is limiting reactant. So HCl is limiting reactant. It makes the least. And then step 3 says that amount is the theoretical yield. So 0.391 moles calcium chloride is the theoretical yield. We could find, if we wanted to, we could find this amount in grams, right? Let's, so.
Won't part B be equal to calcium, not calcium chloride, calcium hydroxide?
Okay, so so for part B, we took calcium hydroxide, we divided by the molar mass, so we got moles of calcium hydroxide. That should be a little 2 there. So I found out the moles of calcium hydroxide, and then I divided by 1 mole of calcium hydroxide reacting makes 1 mole of calcium chloride. So both of these should be calcium chloride, yeah? Doesn't calcium hydroxide need to be subscript of 2? Yes. Sorry, there. Okay. Yeah, sorry. So, okay. Shall we rewrite it then? Let's rewrite it. Okay. So, let's fix it. Sorry, I don't have video editing right now, so this is gonna show the mess first. So it's A was 28.5 grams of HCl, 1 mole HCl over 36.46 grams of HCl, 1 mole of calcium chloride over 2 moles of HCl gave me 0.391 moles of calcium chloride. Second equation, 48.7 grams of calcium hydroxide, 1 mole of calcium hydroxide. 74.10 grams calcium hydroxide. One mole calcium chloride over 1 mole calcium hydroxide. And that one was 0.657 moles of calcium chloride. Now, I can't make that much calcium chloride. It's kind of like when someone said, we were asking how many bicycles, and someone said, ooh, you can make 3 bicycles. With the number of frames I had, I could make 3 bicycles, but I run out of handlebars. This is the maximum here that I could have. So HCl is limiting, and 0.391 moles calcium chloride is theoretical yield. Oh, spelled out. Okay, theoretical yield. We could actually find the mass of this too. Why don't we do an extra step? 0.391 moles of calcium chloride. 1 mole of calcium chloride was, I believe, let's go back here for a sec, was 110.98 grams. I'm going to put that in here too. 110.98 grams. So 0.391 times 110.98. So that means I could also find the amount, which would be 43, let's see, 3 sig figs, 43.4 grams of calcium chloride max. Okay, so that's using the limiting reactant. Move the page. Okay, so let's show that this is the neat one. So there were 2 calculations. We figured out which one made the least amount of product. That gave us what was the limiting reactant, what was the amount of the product. We found the amount in grams. Okay. Okay. So there's a couple other ideas here too. I can find the percent yield. And I can also find the amount of excess left, are some ideas. So let me just continue with this problem, and then we can do some molecule drawings. But all right, so for percent yield, the actual amount of product is usually less than the theoretical yield. There's a lot of reasons for that. For one reason, when there's side reactions, another reason is that once you start making a lot of product, the product can get in the way so that the reactants have a harder time finding each other. They call kinetic argument. Also, another thing about percent yield, so you either in the lab measure, it's either, so the actual, let's put it this way, the actual yield is either measured if we're in a lab or what we call empirical, or in a word problem, it has to be given to you. And so in that case, again, the percent yield is equal to the actual yield divided by the theoretical times 100. And so let's just say, so it has to be given, the actual yield has to be given. So let's just say we obtained 34.85 grams of calcium chloride, comma, what is the percent yield? So the percent yield would be equal to the actual yield, 0.85 grams actual. So the main thing, you could do moles to moles or grams to grams as long as the units cancel. And we also said, let's go back for a sec, that our theoretical yield was 43.4. So 34.8 divided by 43.4 grams theoretical times 100. And then if I look at this, how many sig figs are on the top? Let's move it up. How many sig figs on the top? How many sig figs on the bottom? So it looks to me like four sig figs, four on the top and 3 on the bottom. So my answer should have 3. So that would be 34.85 divided by 43.4. Looks to me like I got times 100, 80.3% would be my yield. Okay, so I don't know if let's see if I have enough time. So that's percent yield. Let's also find the amount of excess left. And so there's a set of steps for this. This may happen on a homework. So the first thing you do is you use the limiting reactant. By the way, the amount of excess left is a theoretical value. We don't really know the amount of excess unless we actually measure it for actual. And then, but usually as a calculation, it's always theoretical. So we use the limiting reactant to calculate the amount of other reactant that reacted. So if we go back to the problem, we had back here, oh, where's the pretty one? There, okay. So we said that the HCl was limiting, the calcium hydroxide was excess. So I had 28.5 grams of HCl. So I'm going to use that. 28.5 grams of HCl, and I got to convert it into moles. 36.46 grams, 1 mole of HCl. To get moles of HCl. Then I need to use the mole ratio. Where's my mole ratio? Way back up here. 2 moles of HCl react with 1 mole of calcium hydroxide. I'm going to plug that in here. 2 moles of HCl react with 1 mole of calcium hydroxide. And 1 mole of calcium hydroxide is 74.10 grams. And so this is going to give me the amount reacted. And it looks like 3 sig figs because of that. And so I get 28.96. Well, it's 3 sig figs, so it actually be 29.0 grams of calcium hydroxide reacted. Okay, so that's the first step. And then the second step is subtract the amount reacted from the total. And so let's go back, way back over here. We had 48.7 grams of calcium hydroxide to begin with. So I'm going to take 48.7 grams of calcium hydroxide total minus 29.0 grams calcium hydroxide reacted, and that's going to give me 19.7 grams of calcium hydroxide left, theoretically. We're going to end in less than a minute, so I'm going to stop the recording here. Do you guys have any questions?